I am Dharmendra Pathak. Today in this video, I am going to describe about basic concept of chemistry, which are basic requirement or basic needs to describe about chemistry. And when we know these basic needs, then other topic that we discuss further in the near future, these all becomes easy to understood and solve various problem or various topic of chemistry. At first, we discuss about what is chemistry. Basic concept of chemistry. We all know that science is the body of knowledge based on practical ideas and experimentation. And in modern concept, science is mainly divided into two parts. These are called types of science. In first type, we study about living organism, which is known as biological science. And in other branch, we study about physical science, or mainly it is also called here about non-living things. It is called physical science. And physical science further subdivided into different branches like physics, chemistry, mathematics. These are the main common branch of science. And here we discuss about chemistry. We can define chemistry by various ways, but actually chemistry include a study of composition of matter, properties of matter, and various types of chemical interaction. Therefore, easily we can define chemistry like the branch of science which deals about structure, properties, and chemical interaction or chemical reaction of matter is called chemistry. Here, chemistry further divided into different sub-branches, like general chemistry is divided into physical chemistry, inorganic chemistry, organic chemistry, and these all sub-branches are according to content or subject matter that contain in it. But as a whole in chemistry, we discuss about structure of matter, from which substance it is made up of, what are its various properties, and what type of chemical reaction takes place or chemical change takes place. And due to that reason, we define chemistry as a branch of science which mainly deals about structure, properties, and chemical interaction of matter or chemical reaction of matter. And from that definition, we conclude that the main topic of chemistry is matter. And we all know that we are surrounded by large number of matters, various type of matters, and everything which are found around us, if it has mass and occupy space, then it is known as matter. And we define simply matter as a anything which occupy space and has mass are called matter. Matters are classified into various types, or different types of matters are found, and on the basis of physical classification, matters are classified into mainly three types. These are solid, liquid, and gas. Liquid, and third type of matter is gas. It is on the basis of physical classification, and here we shortly describe about which type of matter are called solid, liquid, and gas. The first is here the substance which has definite shape, mass, and volume are solid. In solid, these all three components, shape is also remains definite, mass remains definite, and volume is definite, then it is known as solid. Other we can write the matter or substance. In case of liquid, mass and volume remains definite, and here we write which has definite mass and volume. But actually in case of liquid, mass volume remains fixed, therefore definite, but it takes the shape of container, therefore shape remains what? Indefinite. But indefinite shape are called liquid. And third type of, in first matter, these all properties, shape, mass, and volume remains fixed or definite. In second type of matter, in a liquid, shape remains indefinite, but mass and volume remains fixed or definite. But in third, the matter having definite mass, amount of matter in gas remains fixed, definite mass, but indefinite shape and volume are called gas. In gaseous form, only mass remains fixed, but shape and volume remains indefinite. Other properties is here. Molecules are compact in structure, that is tightly packed, and here molecules are loosely packed, then it is called liquid. Molecules are random. Then it is called gas. And in this way, we can differentiate between different or define different type of or physical types of matter. And due to compact structure causes least intermolecular space is found. In case of solid, least intermolecular space and highest molecular attraction found. But in case of liquid, large molecular attraction found. Molecules are apart from each other. Intermolecular space and less intermolecular force of attraction. But in case of gas, negligible intermolecular force of attraction. Molecular attraction and highest intermolecular space. That is, molecules are random. Non-molecular. Also, we can negligible means also no molecular attraction force is found in it. Solid, hard to touch, and less compressibility. When we apply force, then in solid, due to high attraction force causes can't be compressed. It can flow and large compressibility found. Molecules of liquid can be compressed by applying pressure or force. And in case of gas, there is negligible force of attraction, therefore it blow or escape or move randomly, and highest compressibility found. These are general common characteristic of solid, liquid and gaseous state of matter. More detail about the properties of solid, liquid and gas we discuss in state of matter in next chapter. And here, on the basis of chemical classification, matters are classified into two subtypes. On the basis of chemical classification, substance are classified into mainly two types. These are impure substance. Impure means what? It is made up of different kind of matter, different types of molecule in indefinite ratio. Ratio of different kind of molecules does not remains fixed. And here we write the substance which are made up of different kind of molecules or matter are called impure substance, and impure substance are known as mixture. And how we define mixture? The impure substance made up of different kind of matter are called mixture. That mixture is of two types. These are homogeneous mixture and heterogeneous mixture. On the basis of miscibility of component, matters are classified or mixture are classified into two types. These are homogeneous mixture and heterogeneous mixture. How we define homogeneous mixture? So the mixture in which components are uniformly mixed. Uniformly means what? Completely mixed. Then it is known as homogeneous mixture. And we define homogeneous mixture as the mixture in which components means what? The matter which are found in mixture. Completely mixed. Or uniformly mixed, such that can't be seen by naked eye. Can't be seen by naked eye. And due to that reason, components uniformly mixed and difficult for in separation. It is difficult to separate. And here homogeneous mixture are salt solution, air, soda water. In these all mixture we found that components are invisible, can't be seen. Other type of mixture is heterogeneous mixture. Heterogeneous mixture are the mixture in which components are non-uniformly mixed, and we define it the mixture in which components are non-uniformly mixed or not completely mixed. Mixed such that visible by naked eyes. Are called heterogeneous mixture. In heterogeneous mixture we found that components are easily seen, therefore is easy to separate. It is easy in separation. We can easily separate such type of heterogeneous mixture like a muddy water, sand and water, rice and pebbles. Such type of mixture are called heterogeneous. It means component not seen by naked eye uniformly mixed, then it is homogeneous. If components are seen from outside by naked eyes and difficult in separation, then it is known as heterogeneous mixture. Other type of chemical classification of matter are pure substance and the matter which are made up of only one kind of atoms or molecules are called pure substance. In pure substance, particular type of atoms or molecules are present, and the matter which are made up of only one kind of atoms or molecules are called pure substance. And generally elements and compounds are known as pure substance. Element and compounds are example of pure substance. And how we define that element? What is element? So here, any kind of pure substance, if it contains only one kind of atoms, then it is known as element. And any kind of matter or pure substance which are made up of different types of atoms or elements in a definite ratio by weight, then it is known as compound. And now we describe or define elements and compounds with example. At first, element. So the pure substance which are made up of only one kind of atoms are called element. And what are the example of element? Like a hydrogen is element. Certain mass of hydrogen contains hydrogen atom only. Iron is element because iron contains only iron atoms. Gold is example. Gold is element. Why? Because gold element contains only gold atoms. And about that, one 118 elements are known, and among these natural elements are 92 and artificial elements are made by or made in a laboratory. These are about 26. And different elements having different kind of atoms or particular type of elements are made up of particular kind of atoms, and therefore we define atom as a elements are made up of atoms. Here what we should clear that here elements contains atoms, several atoms combined, then it called element. And the smallest particle of an element which take part in chemical reaction are called an atom or simply atom. Atoms are distinct smallest particle of element that have tendency to take part in chemical reaction. And why it is so? Because itself atom is unstable in nature. Atoms are made up of, or atoms are unstable. Why? Because having unfilled valence shell or incomplete valence shell, therefore try to complete it and take part in chemical reaction. It is made up of, or atoms are made up of subatomic particles. These subatomic particles are, when we simple structure we draw about atoms, the entire mass of atoms remains inside the central part called nucleus, and several circular paths found around the nucleus, it is called shell, and electrons are found in shell, and different number of electrons are found in different shell that we detail discuss about structure of atom in atomic structure. And here nucleus contains proton and neutron. Neutrons are present in, and here we describe about that here these elements are represented by, or atoms are represented by short abbreviation, like a example of atoms. Hydrogen is element and its smallest part is called hydrogen atom. Oxygen is element, its smallest particle is called, or single particle of oxygen is called atom. Gold, silver, etc. These all are, it means what? 118 elements are found, then 118 kind of atoms are found or exist. Every kind of element are made up of particular type of atoms, and these atoms and elements are known by symbol. Listen. Short representation used to represent, or short abbreviation used to represent element or atoms is known as what? Symbol. Short abbreviation or representation used to represent element or atom is called symbol. That symbol of an element gives information about that. When we found a symbol of like a H represent hydrogen atom or hydrogen element, yes, and here how we write symbol by various way, like a in some element symbol is taken from its name of first letter, like a hydrogen is represented by H, oxygen is represented by O, particular element having particular type of symbol. In some element symbol is taken from Latin name, like a sodium is represented by Na, natrium that is Latin name, potassium is represented by K, mercury is represented by Hg. Several symbols are used to represent element, and that representation is known as symbol. And while describing about element, to know radical, molecular formula, chemical reaction, you all should learn the symbol of various elements that we provide in a link. And here we should know about short form of that, or short abbreviation used to represent element or atom is called symbol. And what is the meaning of that symbol? Importance of symbol, that is called significance of symbol. Listen. That significance is related to here hydrogen, suppose, or oxygen. If written that oxygen, then what we know that symbol represent particular element. If O written there, then what we know that it is oxygen. Oxygen element is there, oxygen atom. It shows oxygen atom. And it gives information about quantity also. As for example, oxygen represented by O, and here we know that O or 16 gram oxygen, or O written anywhere, then what we know that 1 mole hydrogen, oxygen. That O means simply what we know that qualitative value is here. It represents oxygen atom. And anywhere mention that O, 1 O means what? 18 here, 1 mole of oxygen. That is also known as 6.023 into 10 to the power 23 O atoms. It is called quantitative value. Always here we write that 16 gram oxygen equal to what we know that 6.023 into 10 to the power 23 atoms element, or 16 gram oxygen, that is molecular form, and but in atomic form, element form, its qualitative value is determined with help of symbol. its quantity can be described with help of symbol. Anywhere O mentioned, then what we know that 1 mole of oxygen that represent that much oxygen atom. O mentioned then 16 gram oxygen equal to 1 mole. Yeah. That is equal to that much atoms. And these, listen here, symbol help us to write molecular formula clearly. And here we should describe about in every compound or the other form atoms combine in a definite ratio, then it form compound. Listen. And we define it like a when 2 or more atoms combine in definite ratio or also we can write definite ratio by weight, then it is called compound. Like a water is compound in which hydrogen and oxygen combine in definite ratio. Sodium chloride is compound. Here sodium and chloride or chlorine combine in definite ratio. In different compound we found that ratio of element or atom remains fixed or definite, and these compounds are represented by or smallest particle of compound is called molecule, and that molecule having free existence. It show all the characteristic of compound, and we define smallest particle of the compound which has all the properties of that compound are called molecules. Atoms has dependent or atom has no existence due to unstable, but molecule or compound having existence. In molecules definitely or atoms are present in constant ratio and it has its own identity, and here we write it is stable, that is has free existence, and these molecules are represented by molecular formula. As for example, water is compound, its smaller particle is called molecule. Sodium chloride is compound, like water represented by H2O. The single molecule of water that has free existence is H2O or 1H2O. Sodium chloride NaCl, the smallest particle of that compound is 1 NaCl. One molecule of NaCl is called molecule. And that molecules are represented by molecular formula. How we represent molecule? The molecules are represented by molecular formula. And same as a symbol is used to represent element and atoms, and molecular formula are short abbreviation used to represent molecule of the compound. And here we write short abbreviation used to represent molecules of the compound. Compound is called molecular formula. As for example, water represented by molecular formula H2O. Common salt, oxygen gas is represented by in oxygen molecular formula O2. In gas form, it is diatomic. As for example, glucose is represented by C6H12O6. Several molecules are compound, or each compound having are made up of particular type of molecules, and that representation or presentation of that molecule by using symbol of an element in a definite ratio is known as molecular formula. And here that molecular formula having different significance or having it has its own importance. Like from molecular formula, what we know that water, H2O here mentioned, then what we know that it helps to know molecular formula of water is H2O. It means what? In one molecule of hydrogen, two molecule of water, two hydrogen and one oxygen present. Or by mass 2:16, that is hydrogen and oxygen are present in 1:8 ratio. It helps to know about elements or atoms present in molecule of the compound. Other is here molecular formula is useful to calculate molecular weight or molecular mass of the compound. As for example, 1 mole of water is equal to, how we know 1 mole? That is 6.023 into 10 to the power 23 molecules of H2O. That much in 1 mole, such number of molecules of water found. And when we calculate molecular weight, then we found that 18 gram H2O is known as 1 mole of water. And in this way, from molecular formula and symbol, we get various type of informations. These informations are called significance of symbol and molecular formula. After that, we discuss about radicals. And atoms are unstable in nature. It tries to complete its duplet or octet state by losing or by gaining or by sharing electrons. And in this way, charge gets developed on it and it forms a radical. And we define radical as an atom or group of atoms having charge on them. are called radicals, and radicals retain its identity in chemical reaction, and on the basis of number of atoms present in a radical, it is classified into two types of radicals. On the basis of number of atoms, simple radical. Simple radical means what we conclude that having only one atom, or a radical having or made up of only one atoms, like sodium is simple radical because it contains only one radical. Oxide is simple radical. Chloride is simple radical. Potassium is simple radical. Why? Because only one atoms are present in it. Other is compound radical. If radical contains two or more atoms, then it is called compound. A radical having two or more atoms, then it is known as compound radical. As for example, carbonate made up of carbon and 3 oxygen. Sulfate is made up of sulfur and 4 oxygen. Ammonium made up of nitrogen and 4 hydrogen. Such type of radicals are called compound radicals. Why? Because large number of atoms are present in it. And on the basis of charge, radicals are classified into two types. These are also known as electropositive radical. Electropositive radical having positive charge on them. These are also known as basic radical, having basic property or made from the part of base, and here we call having positive charge on them. Like several electropositive radicals are present, and here in short here we describe some common positive radicals and electronegative radicals. At first we define about electropositive radicals. Other type is here electronegative radicals. Electronegative radicals are called acid radical. Acid radical having negative charge on them. And now we describe some common types of electropositive and negative radicals, and also I will provide you the different important electropositive and negative radicals. At first here on board we write some electropositive radicals, and more about the electropositive radical I will provide in comment or in a link. radicals. Some common electropositive radicals which are frequently used in chemical reaction or while writing molecular formula are hydrogen, represented by H plus, having only one valence. Lithium, represented by Li plus. Beryllium, represented by Be plus plus. Boron, represented by B plus plus plus. Sodium, represented by Na plus, having valency equal to number of charge present in it. Potassium, represented by K plus. Magnesium, represented by Mg plus plus. Calcium, represented by Ca plus plus. Aluminium, represented by Al3 plus, or having 3 valence. Zinc, represented by Zn plus. Ammonium, represented by NH4 plus, having valency 1. Silver, represented by Ag plus. Ferrous, represented by Fe plus plus. Ferric, represented by Fe3 plus. Cuprous, represented by Cu plus. Cupric, represented by Cu plus plus. Plumbous, represented by Pb plus plus. Plumbic, represented by Pb4 plus. Stannous, Sn plus plus. Stannic, Sn4 plus. Manganese, Mn plus plus. Manganic, Mn3 plus. Chromium, Cr3 plus. Gold, Aurus, Au plus. Auric, Au3 plus. And several electropositive more radicals are found, and try to copy from your book or copy from here, that will be useful to write molecular formula. Now we discuss about some common electronegative radical like mercury, Hg plus. Mercuric, Hg plus plus. And now we write electronegative radicals. And here we write some common electronegative radicals, copy from here or copy from your book, and then we practice how to write molecular formula and chemical reaction. At first, fluoride, F minus. Chloride, represented by Cl minus. Bromide, represented by Br minus. Iodide, represented by I minus. Hydride, then represented by H minus. Oxide, represented by O minus minus. Peroxide, or peroxide O2 minus minus, sulfide S minus minus, nitride represented by N minus minus minus, and chlorate represented by ClO3 minus, hydroxide represented by OH minus, and some more electronegative radicals are nitrate represented by NO3 minus, nitrite represented by NO2 minus, bicarbonate or hydrogen carbonate represented by HCO3 minus, bisulfate or hydrogen sulfate represented by HSO4 minus, sulfate is represented by SO4 minus minus, carbonate is represented by CO3 minus minus, permanganate represented by MnO4 minus, silicate represented by SiO3 minus minus, phosphate represented by PO4 minus minus minus, phosphite represented by PO3 minus minus minus. Phosphide can be represented by P minus minus minus. Several more electronegative radicals are found, and here we summarize some, like a phosphide we discussed that, chlorate already we discussed, cyanide represented by Cn minus, sulfite represented by SO3 minus minus, zincate ZnO2 minus, chromate or dichromate represented by Cr2O7 minus minus. And these are the common electronegative radicals which are most essential to write molecular formula of the compound. In the next video we discuss more about how to write molecular formula, how to calculate molecular weight of the compound, how to write balanced chemical equation of the compound, and then about the types of chemical reaction and more basic terms which are essential in chemistry, and then more chapter related to that. Therefore, to know about chemistry,